In chapter 5.3, we look at covalent bonding. I've drawn for you two sodium atoms. Sodium is in group 7, therefore it's got 7 electrons in its outer shell. Because it's got 7, it wants to gain 1 electron to have a full outer shell. Because both chlorine atoms want to gain an electron, the only way they can both end up with a full outer shell is if they share electrons. And when they do this, you end up with the following diagram. I still have 7 dots for the first chlorine atom, and I've got 7 crosses for the second chlorine atom. But the 2 electrons that exist between them are now being shared between both chlorine atoms. That means this chlorine has 2, 4, 6, 8 electrons, and this chlorine has 2, 4, 6, 8 electrons. These electrons in the middle are being shared. Okay? We know that electrons are negatively charged, so these electrons here in the middle are going to be negatively charged. And for both chlorine atoms, you're going to have a positive nucleus. So there's an electrostatic force between the negative electrons in the middle and the positive nuclei on either side. And that electrostatic force between the shared electrons and the positive nuclei is a covalent bond. Okay, so a covalent bond is the electrostatic force between the shared electrons and the positive nuclei of the 2 bonding atoms. Okay, in general, when you've got 2 nonmetals, they will always form covalent bonds. Okay, nonmetals always want to gain electrons, so in order for them to react with each other, they will end up sharing electrons and forming covalent bonds. At GCSE, we always would have drawn circles. It's totally fine to still draw your electrons in circles and then draw 2 circles overlapping here, but you don't need to draw the circles. As long as you have the 2 electrons in the center, it's clear which electrons are being shared. If we look at another example, I've got nitrogen. Nitrogen's in group 5, so has 5 electrons in its outer shell. It therefore wants to gain another 3. Hydrogen has 1 electron. Its outer shell is the first shell. If it gains 1 more electron, it will have a full shell. Because nitrogen wants to gain 3 electrons, it wants to form 3 bonds. So when nitrogen and hydrogen react, you form ammonia, which is NH3. Okay? Nitrogen wants to gain 3 electrons, so it will form 3 bonds. So you can see 3 of nitrogen's 5 electrons are involved in bonds with hydrogen, but nitrogen still has 2 electrons to itself as a lone pair. Hydrogen only has 1 electron, okay? It wants to gain another electron, so it will share the only electron it has and form a bond. Then nitrogen ends up with 2, 4, 6, 8 electrons, so it has a full outer shell, and each hydrogen atom has 2, so each hydrogen also has a full outer shell and is happy, okay? Again, each of these pairs of electrons represent a covalent bond. So these electrons, which are negatively charged, are attracted to the positive nuclei of hydrogen and the positive nuclei of nitrogen, and they are held together. When nonmetals covalently bond, we say they form molecules. Now, this word molecule is often misused. The only time you should be using the word molecule is when you're talking about atoms that are covalently bonded together. You should never be using the word molecule when you're talking about an ionic compound. Okay, molecules should not contain metals. They are formed when nonmetals covalently bond to each other. So you should only use the word molecule when you're talking about covalently bonded atoms. Okay, you'll also notice I'm saying the word atom here. Okay, these atoms are sharing electrons. They're not losing or gaining, so we're not calling them ions, and they are not charged. Okay, molecules are typically much, much smaller than ionic compounds. When we had an ionic compound, so for example, when I had sodium chloride, I had sodium as a positively charged ion, and sodium could attract negative charged chloride ions all around it. Okay, so there was lots of space for negative ions to come in and bond to sodium, and this attraction was going in all directions. Because you've got this attraction going in all directions, you ended up forming this giant ionic lattice where every ion was attracted to lots of other oppositely charged ions, and you form this big giant ionic lattice. With covalent molecules, the attraction only exists between the 2 bonded atoms, and molecules are much, much smaller. Okay, you don't have a giant structure like we did before. You've got a small molecule, and you know exactly how many atoms you've got. So for example, in ammonia, NH3, I've got 1 nitrogen and 3 hydrogen. They're the only 4 atoms in an ammonia molecule. In Cl2, I've just got 2 chlorine atoms in a Cl2 molecule. I don't have any others, okay? When we had ionic compounds and we had NaCl, that NaCl was just a ratio. It told me I had the same number of sodium ions and chloride ions, but I could have billions of sodium ions and billions of chloride ions. Okay, I don't know how many I've got. It's giant. With molecules, I do know how many I've got. Okay, these numbers aren't just a ratio. They tell me exactly how many atoms I've got within a molecule. Okay, so covalent molecules much smaller than what we had before with ionic compounds. It's important to know how many covalent bonds atoms are going to want to form. Okay, so if we look at our periodic table, we can see carbon is in group 4. Because it's in group 4, it wants to gain 4 electrons, and if it wants to gain 4 electrons, it will form 4 bonds. So a typical molecule containing carbon would be CH4. Nitrogen we've just seen, okay, it wants to gain 3 electrons, therefore it wants to form 3 bonds, and we've just seen NH3. Oxygen wants to gain 2 electrons, therefore oxygen wants to form 2 bonds. Classic example would be H2O. Fluorine's in group 7, it wants to gain 1 electron, so it will form 1 bond, HF. And then hydrogen, which we've seen, wants to gain 1 electron, so hydrogen can only form 1 bond. Okay, all of these atoms here are following the full outer shell rule. They're all sharing electrons so that they end up with a full outer shell. Because carbon is 4 electrons away from the full outer shell, it will form 4 bonds, and it will always form, always form 4 bonds. However, when we go on a little bit further, okay, so we've looked at hydrogen, we've looked at carbon, nitrogen, oxygen, and fluorine. Okay, remember our noble gases aren't forming bonds; they already have the full outer shell, so they're unreactive. And we're never looking over here. We're not looking at metals at all. We're only looking at non-metals. Okay, but if I go down to period 3, the likes of phosphorus and sulfur and chlorine. Okay, at GCSE we learned that the third shell could only hold 8 electrons. Okay, but now we know that the third shell can actually hold more electrons. That means phosphorus and sulfur and chlorine, they can form more bonds. So phosphorus is in group 3, the same as nitrogen. We would have learned at GCSE, if it's in group 3, it wants to gain 3 electrons. And phosphorus does sometimes form 3 bonds, okay? So common compound, pH3, it's forming 3 bonds. But because that third shell isn't actually full, phosphorus can form more bonds. It has 5 outer shell electrons. It can form up to 5 bonds, okay? Phosphorus can form 5 bonds. If we look at sulfur, same group as oxygen, so we would normally say that it wants to gain 2 electrons, okay? And sulfur does form compounds where it's just gaining 2 electrons and it's forming 2 new bonds, but it has 6 outer shell electrons and it can form up to 6 bonds, okay? Chlorine, we've seen chlorine, we'd say it wants to gain 1 electron. Common compound would be HCl, but chlorine has 7 outer shell electrons and it can form up to 7 covalent bonds, okay? Remember that third shell doesn't just hold 8 electrons, it can hold up to 18, which means these bigger atoms in period 3 can form more bonds. Okay, to know how many they can form, you look at how many outer shell electrons they actually have. If phosphorus only has 5 outer shell electrons, the maximum number of bonds it can form would be 5. Chlorine has 7 outer shell electrons, the maximum number of bonds it can form will be 7. Okay, in the next video, I'm going to go through lots of examples, some that you would have come across at GCSE, some that you definitely won't. I'm just going to practice drawing loads and loads of dot cross diagrams. It's a really common exam question and something that you definitely need to be able to do.